Hello everyone, and welcome back to our next video for Calc 1. This is on section 1.4, which is called Limits at Infinity, and we'll explain how that works as we go on here. So to start off with, I want you all to go ahead and pause the video and graph the function that we've got up here. F of x equals x plus 1 over x minus 1. I've made you a little table. I've actually made two, but you only have to worry about this first table for right now. Go ahead and fill that out. You will find a problem at one of those places, but it's something we dealt with in the last section on infinite limits, so you're going to find a problem there, and you're going to figure out exactly where we have a vertical asymptote and how the graph looks at that vertical asymptote. So it should be things we've already done at this point. So go ahead and pause the video and fill that out, and then afterwards we'll talk about this second table. But we'll get to that now in a little bit. Okay, if you're all back, we can go ahead and finish this up. Let me actually write the function out here so I've got it in front of me. This is x plus 1 x plus 1 over x minus 1. Okay, so I'll need that to be able to fill in these numbers. So if I take negative 4 plus 1, I get negative 3. Negative 4 minus 1, I get negative 5. So here I would get negative 3/5. Sorry, negative 3 over negative 5, which should be positive 3/5. Sorry about that. Negative 3 plugging in there, I should get negative 2 over negative 4, which would wind up being 2/4, or let's go back, 1/2. If I plug in negative 2, I should get negative 2 plus 1 is negative 1 over negative 2 minus 1 is negative 3, so that should be 1/3. If I plug in negative 1, the top is x is minus 1 plus 1, which is 0. The bottom is negative 2, so this one gives me 0. 0, I should get plus 1 over minus 1, so negative 1 there. 1 is the one I already mentioned where it doesn't exist, right? So we get 2 over 0, so that doesn't exist. Let's put that in red. And here, does not exist. 2, we get 3 over 1, or just 3. For 3, we get 4 over 2, which winds up being 2. For 4, we get 5 over 3, or 5/3. And for 5, we get 6 over 4, or 3/2. So these should be the values you found. We can go ahead and plot those on our graph. Let me put the points in blue. Okay, so negative 4 3/5 is right about here or so. Negative 3 1/2. Wait, let me make sure I'm doing this right. Yeah, negative 3 1/2. Okay, lost it. There we go. It's right about here. Negative 2 1/3 is right about here. negative 1, 0 is there. 0, negative 1 is right there. 1 is the place where it doesn't exist. And we'll go ahead and put this in right now as an asymptote. You should have figured out that that's where the asymptote would be from what we did last time. Let's go ahead and put the asymptote in here. Okay, so there's your vertical asymptote, which would be x equals 1. Okay, so we've got that. Those are all the points we've graphed so far. The other side we get the point 2, 3. So 2, 3 is easy enough, it's right here. The next one is 3, 2. That is right here. Next one is 4, 5/3, which is 1 2/3, or right about there. The next one is 5, 3/2, which is 1 1/2, which puts us right about, right about here. Okay, let me make sure all these points are big enough to see. That looks good. Okay, so now what we should be able to do here, and what you should have done so far, and I'll maybe talk about an extra point or two here. If we plug in a half, if we look at what we should get a half plus 1, which is 3/2, over a half minus 1, which is negative a half. So that should give us negative 3. So right down here for negative 3 1/2, and we can already see what's going to happen there. If we plug in 1 1/2, we should get 1 1/2 plus 1, which is 2 1/2, or 5/2, over 1 1/2 minus 1, which is a half. So that should give us about 5, which is right about here, that point. So you can see just from plotting the extra point where the asymptote is. Let's go ahead and fill in the curve here. This is going to be a little bit rough because these aren't perfect, but actually, no, that'll do. Okay, and we should get something that goes like that for our one piece of our graph. And for our other piece of our graph, we should get something that goes roughly like this. Oops. Okay. So we should get something that looks roughly like that. Similar to what we saw last time, maybe a little bit different, but the same general idea. What we want to look at now is filling in this second chart of values. Now, these are going to be a little bit more complicated, but you can still do them fine on your calculator. It's no big deal. So what I'd like for you all to do is plug in all of these values on your calculator, come back, and we'll talk about what those values are and what that means. So pause the video and do that. Okay, if you are back, hang on, let me see if I can, there we go. If you're back, we should be able to get these. Let me go ahead and fill the function in again. This is x plus 1 over x minus 1. And if we look at this, we should get essentially negative 999 over negative 1001. Actually, those are both negative, but let me go ahead and cancel the negatives here. So we get 999 over 1001. The next one down, when we plug in negative 100, we should get 99 over 101. If we plug in 10, we should get 9 over 11. If we plug in, negative 10. These were all negatives. If we plug in 10, we should get 11 over 9. These are just going to be essentially flipped. 11 over 9, 101 over 99, and 1001 over 999. Normally, I would have you all give me the decimals of these, but let me type this into my calculator here, and I'll get those out to a couple decimal places. It's going to be a couple minutes here to get them all. So our first one, 999 divided by 1001, that is 0.998. The next one's 99 over 101. That's 0.980. The next one's, 9/11. That's 0.82. Let's make it 0.818. It is about 0.82, but we'll go ahead and get these exact if we can. The next one is, sorry about that, 11 over 9. That's 1.222. And the next one is 101 over 99. That's 1.02. Or 020. And the next one is 1001 divided by 999, which is 1.002. So what you'll notice here, if we're looking at these values, especially as we go further out, so away from 0, either towards infinity or towards negative infinity. In other words, bigger values but with a minus sign on them. Either way, it looks like we're closing in on this value here. What those values are is, you'll notice from both sides here, and we can even go further and see this in even more detail, but both of these directions look like we're closing in on 1. And if we look at our graph over here, it does indeed look like we're getting closer to 1 as we go out in either direction. And in fact, that gives us another thing to talk about here, actually 2 other things to talk about. One, hang on, I didn't need to go that far, did I? All right, so what we see here is we're getting a limit, but a different kind of limit than we've looked at so far. The kind of limit that we're looking at here is a limit for the function as x goes to infinity. So not where the limit equals infinity, but where the x value is approaching infinity. So that's what we're looking at here. And so that's the limit version of this. But we also can talk about this as another type of asymptote. And you can probably guess what type of asymptote it is by the line I just drew here. We would call this a horizontal asymptote as opposed to our vertical asymptote. Now, we haven't gotten into the details here, but if you had to guess what our horizontal asymptote is here, what line would you say it is? Go ahead and pause the video and think about that and write it down, and then you can check. Well, the horizontal asymptote that we're seeing here, and we will find out that this is accurate, that's the line y equals 1. I should underline it too. There we go. Okay. So that is the situation we're in here. So we're looking limits at infinity. In other words, what happens as we let x go to infinity or to minus infinity? In other words, to infinity but with negative signs attached to it. So that's what we are doing here. So let's go ahead and explain what this means. I guess I should write this out. So we say limit as x goes to infinity of f of x equals, I'm going to put an L here, but that's just a number, right? So that you don't have to worry about what L here is. It's just some number. Okay, so we say that the limit as x approaches infinity of f of x is L if the y value of our function, sorry about zooming in, but it is the only way I can write legibly. It's not quite as easy as on a chalkboard on this thing. If the y value approaches, in other words, gets closer to, as x gets bigger and bigger. So the y value gets closer to L as x gets larger and larger without pound. Okay, so that is what we mean by the limit of x approaching infinity of f of x is L. Similarly, if I'm going to leave off some of what I'm writing here just to save a little bit of time, but if I say the limit of f of x as x approaches minus infinity is L, it's the same idea, but here, if the y value approaches L, and let me put in some little, what do you call them, ditto marks here. As x gets smaller, in other words, goes toward negative values without bound. So that is what we mean by a limit at infinity. Okay, so hopefully that makes sense. That is actually a lot smaller than I thought, but it'll be okay. Let me make this legible though. because you will have this PDF and I want it to be readable. Okay, so that is what we mean by limits at infinity. Now, also though, this ties into a horizontal asymptote. In fact, let me type this out here. There we go. And how we can talk about horizontal asymptotes is if the limit as x goes to plus or minus infinity. So if either of these limits equals L, y equals L is a horizontal asymptote for our function. That's what we mean by a horizontal asymptote. But in other words, it's a line that our function, a horizontal line that our function gets closer to as we go out to the side. There we go. So that's what we mean by a horizontal asymptote. So here we can see that our limit actually does look like it's going toward 1, and we can see that we're getting that horizontal asymptote because of that. Now you'll notice here I say if it goes to plus or minus infinity, if these limits on either side go to different things, you can have two horizontal asymptotes. But you actually have to set up your function a little bit weird to have that happen. If you have a function like the one we have up above, like this one right here, hang on, like this one right here, if you have a function like that, you can't really have two horizontal asymptotes. You have to set up something a little bit weirder because a function like this, the limit as you go toward infinity or towards negative infinity is going to be the same. And we'll see that here in a second when we get to the rules about limits at infinity. In fact, let's do that right now. There we go. So let's talk about this here, our rules for limits at infinity. Essentially, we're interested in a couple of different kinds of functions. So mainly here what we're interested in is if we have you can actually get more complicated functions than this and answer questions about limits at infinity, but this is where we're going to sort of stop. If you have a function of the form f of x equals, and I'm going to write this in words here and we'll look at examples in a second, but one polynomial over another polynomial and here remember polynomials are essentially sums of powers of x. So like when I say a polynomial, let's put a quick example up here. So an example of a polynomial might be, I'll even put a couple of examples here. One example would be x plus 3. Another one might be 2x squared minus 4x plus 7. And another one might be 5x cubed minus 111x squared plus x plus 309. So they can get big, they can get complicated, but the idea is they're always sums of powers of x with constant coefficients. Those are what we're looking at for a polynomial. So if we have a function of that form, essentially we have a very short solution to figure out what our limits at infinity are. So if we have that, we can find limit as x goes to plus or minus infinity of f of x, and they'll be the same. Limit as x goes to plus or minus infinity of f of x, they will be the same, but we can find that by the following rules. I don't need that period yet. By the rules below. And maybe I'll actually type this out. I probably should have been typing some of this stuff out already. But let's go ahead and type this one out. Let's do a star there. If the power, let me phrase it a little bit better here. If the highest power of x on top is bigger than the highest power on the bottom, well, pause it for a second and think about what you would expect to happen if the highest power on top is bigger than the highest power on the bottom. How would you expect those values to compare to one another? And what would you expect to happen as you plug in bigger and bigger numbers? Well, what we find is if the highest power on top is bigger than the highest power on the bottom, these values keep increasing, so we say there is no limit. And so there is also no horizontal asymptote. Let me edit this again here. There we go. So that's our first one. If the highest power of x on top is bigger than the highest power on the bottom, there is no limit, and so there is no horizontal asymptote. Well, let's go ahead and paste that here. What would our next situation be? Go ahead and pause this and think, what's another situation? Here we've already looked at the power of x on top is bigger. What would another situation be? Well, if you're back, the next situation we can have is instead of the power on top being bigger, we can have the power on the bottom being bigger than the power on the top. There we go. If the power on the bottom is bigger than the highest power on the top, here there is a limit. The limit is always 0. And so the horizontal asymptote is y equals 0. So we have a second situation here. The highest power on the bottom is bigger, then the limit is 0. Here you can think about that. The bottom is getting big faster than the top. So if we have a fraction where the top is much smaller than the bottom, we're getting something close to 0. Now we have one other situation, which you might have guessed what it will be, which is, well, what's our last possible situation? If the highest power of x on top is the same as the highest power on the bottom, the limit is the ratio of the coefficients of that highest power. And that is also the horizontal asymptote. So here that might be, hang on, there we go. So let's take a look at this last case because we've already done an example here. So here you'll notice in this example we did up here, our highest power of x on top and the bottom, both situations is, both of these are x to the first. So these are the same. And so how we find the limit then is limit as x goes to infinity. Let me make it plus or minus infinity of f of x equals the ratio of their coefficients. So what am I multiplying x by on top and bottom? Well, this is essentially, both of these are 1x squared, right? Or 1x to the first. So the ratio of those coefficients then is 1 over 1, which that gives us a limit of 1. So that's how we use this last situation. And hopefully that makes sense. Let's actually do a few examples here. Hang on. Okay. Let me give you 3 examples. I'm just going to make these up off the top of my head. It won't matter though. They're all going to be pretty much the same kind of thing. So let's start off with a first one. So let's say find, I'm only going to write limit as x goes to infinity or minus infinity here. But remember, if we have this kind of function, they are the same, so it doesn't matter. Let's see, so x cubed minus 2x squared plus 8x minus 6 over 13x to the fourth minus 11x cubed plus 2. Now, I know this looks awful. It was intended to look awful, but not to be awful. So what I would like for you all to do, we're going to do these examples one at a time. I'll do this one, then another, and then another. So go ahead and pause this video, look at the rules here, and see which rule applies and what that means about what this limit should be. So go ahead and do that. Okay, if we're back, let's take a look at these powers. The power that we have on top is 3. The power that we have on the bottom is 4. So if we look at our rules here, which situation are we in? Well, highest power on top is bigger than the highest power on the bottom. Well, that's not true here. 3 is smaller than 4. So here we're in this second situation. The highest power on top, on the bottom, is bigger than the highest power on the top. And we find then there's nothing to do except say the limit is 0. And if we're asked to find the horizontal asymptote, that's the same thing. Horizontal asymptote is y equals 0. And we're done. Okay. Hopefully that makes sense. So that's our first example. Hopefully that was pretty easy. Let's pick another one. There we go. I'll do 3 different highlighter colors here. Our next one, let me go down one more line here. We'll find the limit as x goes to infinity. And again, I'm going to make all these look awful. But just because they look awful doesn't mean that they're going to be any harder than one that looks simple. I'm just sort of getting you in the practice of realizing that that it doesn't really matter much what's going on except on these first terms. Okay, so 5x to the 7th already looks good, doesn't it? Minus 11x to the 4th plus 6x cubed minus x. And on the bottom, we will have, let me give myself a little bit of room here. We will have 12x to the 4th plus x cubed plus 12x squared plus x plus 12. Okay. It looks like something special is going on the bottom. You'll find that it's not. So go ahead and look at this one again. Again, look at the rules while you're doing it. So find the limit of this one. What's going on with the top? What's going on with the bottom? What's the highest power on each and how do they compare? So go ahead and pause this and come up with that. All right, if you're back, then we can notice, starting off, highest power on top is 7, highest power on the bottom is 4. How do they compare? Well, the highest power on top is the bigger one. That means we're in the first case here. That means there is no limit. So we can say this limit does not exist. Now, if you want to ask, does this go upward toward infinity or downward toward negative infinity, you can actually figure that out as well based on the signs of these things, but we won't quite get into that just yet. But once we see this limit doesn't exist, we see we have no, I didn't need the period there, we have no horizontal asymptote, and so that one is done. Okay, so hopefully these are making sense to you still. Let's go ahead, green next. All right. Oops, that is not what I wanted to do. All right, let's go in here, do the last one, find the limit. Well, you can almost guess what the next situation is going to be because I've only got one left, but let's go ahead and do it. Okay, so here we want to find the limit of 7x cubed plus x minus 1 over 5x cubed minus 12. This one looks simpler than the other two, but truth is none of these are actually that simple. If you had to factor any of them, presumably you wouldn't actually be able to factor any of them, but we don't have to do that here. We just got to compare powers on top and bottom. So go ahead and pause the video and figure out what you need to do here. All right, if you're back, what we see about the powers on top and bottom here is they are the same. That's our third case here. And in the third case, we want the limit to be the ratio of the coefficients. Well, the ratio of these two coefficients, the coefficient of the first power is 7, or of the top, sorry, is 7. The coefficient of the bottom is 5. So the limit is the ratio of that coefficient, of those coefficients, in other words, 7 over 5, and that means the horizontal asymptote is exactly the same thing, y equals 7/5. And that is how we find these limits and the horizontal asymptotes. Hang on here a second. And let me fix this up a little bit. It'll look better when you have a, what do you call it, when you get done with this and want to look at the PDF. All right, so that is it for today. I'm going to go ahead and post this, and if you have any questions, let me know. This is the 1.4 video, so if you have any questions on it or the homework related to it, please let me know. I'm always available on the Google Hangouts chat, and I'm available by email, and I can be available by video chat if you would prefer that as well. All right, I will see you all later. Hang on, let's do this one too while I'm at it. I will see you all later, and have a good day. Bye.